Here we show an example of a non-Newtonian fluid. This is a simple mixture of cornstarch and water. This mixture is sometimes called oobleck. Oobleck is an example of a shear thickening fluid. This means that as a force is applied to the fluid increases in viscosity. Watch as a force is applied how the oobleck turns to what appears to be a solid, but as the force is released, the oobleck returns to a liquid state. Why this happens will be discussed later. So there are two theories as to why shear thickening occurs. The first is called hydrodynamic clustering, which occurs when particles in a colloidal are pushed together, and the fluid between the particles is squeezed out from between the particles until only a small film remains. So using these ping pong balls as an example of the particles in a colloidal, in the first theory, the particles will be pushed together and the fluid between the particles will be removed until at some point you cannot remove any more fluid, and then these particles will be locked together kind of as a cluster and they'll move, right? Which will make it more difficult to move the fluid. So the particles do not come in contact because of the high forces that lock the fluid between the particles, and then these forces will eventually lock the particles together, forming a cluster. The second theory is that the particles actually do come in contact. So what happens is the force is applied and the particles will move together until eventually they come in contact, and then the force between these two, the friction force between these two particles, is what locks them together as a cluster, which then makes it difficult to move, right? So these are the two theories that have been debated as to why a non-Newtonian fluid reacts to shear and becomes thicker.
So the idea of the experiment is pretty simple. We use a rheometer. Basically, it's a cone with a plate, and we sandwich the suspension or the sample shear thickening fluid in between this geometry. And the idea of the experiment is I'm going to put the cone in the suspension, the shear thickening fluid, and work to turn this clockwise until it reaches a steady state. Then immediately I'm going to reverse the direction of the stirring. And then you immediately record the instantaneous response of the sample. And so the hypothesis, if the response is hydrodynamic, which means most of the contribution comes from the background liquid, you're supposed to get exactly the same viscosity or the response of the sample. But if it's because of the contact force, since the stress is being released, you're supposed to see a sudden drop of the force that indicates, it is really because of the frictional force between particles that gives you the shear thickening. And what we really found was really striking. We find immediately after we reversed the stirring direction, we saw a sudden drop of the force. That's actually a smoking gun evidence showing you that the frictional force is the dominant role in shear thickening mechanism.